today for this 1-hour webinar on battery storage for community buildings. My name is Luke Wilkinson and I'm from Sustainability Victoria. We're an agency of the Victorian State Government charged with supporting Victorians to use resources more sustainably and to take action on climate change. We're really pleased today to support this webinar and bring together some introductory information on battery storage for local government and for community energy groups. Today is going to focus on battery storage and how applicable it is for community buildings. In our conversations with local government and with community energy groups, we know that there is interest in this topic and in this opportunity out in the community. And we often find, and often we've found that the community energy groups or council officers are being approached by organisations that want to put batteries on their community buildings. So you're getting asked for information, advice, and even support for these battery storage projects on local buildings. So we thought it would be good to have the webinar today and aim to connect you with information that I hope will assist you in these conversations with your community energy groups. I'd really like to introduce and thank you to Andrew Redaway, Energy Analyst with Renew. Andrew will be known to many of you with his time at Renew and also over the last 5 years at the Alternative Technology Association, ATA, that is now Renew. He also designed and developed the Sunulator tool that many of you, and I know us, we use when we're working with and encourage councils and community energy groups to use that resource and tool. So that's thanks to Andrew. Before I hand over to Andrew to kick off the webinar, just a bit of housekeeping. The format will be that Andrew will run through a presentation, then you'll be able to hear it and view it on your screen. You're able to post questions as Andrew is going through the presentation by typing into the Skype Q&A that should be on either the side or the bottom of the screen, depending on how your screen is set up. And hopefully we can address those questions as they come in. So that they can relate to what Andrew is talking about at the time. Or we've also allocated some time at the end of the hour, towards the end of the hour, to go through any questions and answers. The webinar today is going to be recorded, and I will forward a link of the recording onto you, as well as a PDF of the slide deck. I really encourage you to share the recording and reference the work in your conversations with either your council teams or your community energy colleagues. Today's going to touch on battery storage as it relates to community buildings, and we're going to touch on the technology, but we won't really have a lot of time to delve into the detail. So it's a bit of a taster. We'll also touch lightly on battery storage for households, because we know as council officers or community energy groups, you might be getting approached by local residents saying, what about putting battery on my house? So we'll touch on that, but really the focus is on your typical community buildings. Yeah, so that's it. Over to you, Andrew. Walk us through it.
Well, thanks for the kind introduction. That's great. So just for those who are not familiar with Renew as an organisation, we're a not-for-profit national organisation. We've been around since 1980 and we're member-based. So mostly our members are households. We do a bunch of things. I'm in the policy and research team. So the slide here shows how we do research on various topics. We've got reports and publications. You can look at it on our website. We do project consulting, advocacy in the energy market, etc. And we've got some tools that are there to be used as well. We do a bunch of other things as an organisation. We've got publications, we do events. Sustainable House Day is coming up on the 15th of September, so that might be worth publicising so people can go and visit sustainable homes. All right, so I thought I'd start off with a case study just so we can get something tangible to sink our teeth into. So Nillumbik. So this is a council-owned sports stadium in Diamond Creek, and it's been designated as an emergency refuge for bushfires. So it can hold up to 1,000 people in an emergency event like that. And it's had installed solar and also batteries. And with the combination of those, they say it can go off-grid for up to 8 hours. And they got some funding from the state government's New Energy Jobs Fund, actually in 2 rounds of that. The project also included an electric vehicle charger at the site and some lighting upgrades. So with the solar and batteries, so there's 333 solar panels, and the total rated capacity is just under 100 kilowatts of power. So you can see there that you need about 3 panels to get 1 kilowatt. A kilowatt's somewhat more than a horsepower, just to give you an idea of how much power that is. With the batteries, the energy storage capacity is 100 kilowatt hours of energy, which is pretty big. So as a point of reference, a battery at a household, you might be looking at between 5 to 13 kilowatt hours. It's a good quality gear that they've used, and it also includes monitoring with a screen on site that the people can see what's going on with the solar on a live basis. So the cost for it, about $440,000, but because of those support from the state government, the cost to the council was a fair bit less, only a bit over 200,000. And yeah, the installation team's there. In fact, the older guy in the middle has some connections with Renew, so I should put a disclaimer there, I guess. Okay, so some points to note about this project. So 100 kilowatts is a pretty common size for larger scale buildings, and it's a bit of a sweet spot for a solar installation, just because of the rebates and discounts that are available. So there's a thing called a Small Technology Certificate, an STC, which is it can be effectively applied as a point of sale discount and built into the price of a solar system. It just depends on the capacity of the solar panels, and yeah, it can be applied as a point of sale discount up to less than 100 kilowatts. So if you put on a system on a single electricity billing meter that's bigger than 100 kilowatts, then it becomes more of a headache. You have to you can't have that as a reduction in the cost of the system. It's the benefits have to be manually claimed each year. So yeah, that becomes a bit of a headache. Another point is around the cost. So let's say instead of going solar and batteries, they decided to just put in a standard Grid Connect solar system, again with 100 kilowatts of panels, or 333 panels. So for a project like that, you'd expect it to cost maybe $100,000 or maybe a bit more than that, depending on the quality of the gear, etc. So this project cost around 4 times as much. Now part of that will be due to the electric vehicle charger and the lighting upgrades, the monitoring, but most of that difference would be in the batteries and the associated inverters and things that are needed with those batteries for a true off-grid capability. So you can see that that's pretty expensive. The batteries are a lot more expensive than solar panels, basically. And And if you look at the bill savings, the bill savings are mostly due to the solar panels. Adding the batteries is going to provide additional bill savings. It's going to enhance the bill savings that you get from the panels, but it's not going to be proportional to the extra cost. And we'll come back to that later. But in this case, the real rationale for the batteries wasn't so much to provide additional bill savings. It was more around the emergency benefits as a bushfire refuge. Okay, so that may be raising some questions in your minds, perhaps, about what would make a community building a good candidate to have a battery installed. Now, batteries are normally installed alongside solar or as an addition to a solar system. So things that might make it a good candidate would be if you need an off-grid capability or blackout backup, such as the Nillumbik example. Another one would be if your local poles and wires company, the distributor, has when you've gone to or your solar installer has gone to request a connection into the grid, the company's come back and said, okay, yes, you can put a solar system on, but only if you limit the amount of power that you're ever going to export. So if you had 100 kilowatts of panels, they might say, okay, you can only, at any point in time, you can only export 30 kilowatts or 10 kilowatts or even 0. So if that's the case, then when it's a sunny day, those panels, they'll be supplying your appliances on site, but they'll have additional power generating capacity that's being wasted, and because normally it would be exported to the grid, but that may be curtailed at a certain level. So if you've got solar generation which is being wasted for a reason like that, then that starts to make more sense to put a battery in, so that power that would have otherwise been wasted can be saved in the battery for use later on. A similar case is where you have issues with the voltage in the grid. So voltage is meant to be 230, 240 volts, as we're familiar with our households, but it actually does vary over a surprisingly wide band for a whole bunch of reasons. And if that grid voltage in the street gets out of spec and gets too high, then your solar inverter can throttle back as a way to play nicely with the grid and not exacerbate that high voltage. So batteries that's another case where you may be effectively wasting some generation from the solar panels, and there are some battery systems that can, instead of wasting it, can save that in the battery instead.
Andrew, I might just jump in there. There's a couple of questions coming through, which is great. Thank you. Good one here from Carly about, is the fact that for a community building where maybe 8% of the usage at night is at night, outside the time of sunlight solar generation, is that a good enough reason to be thinking about that as building as a candidate for batteries?
Well, I guess it depends what you're trying to achieve. If it's about reducing the bills, then we'll look at this a bit later on and a little bit more, but the battery is going to be not really economic for that purpose. Because yes, the battery can supply power during the night, and that's going to reduce your bills, but the upfront cost of the battery is so high that it's not an economic prospect.
Yeah, okay.
Yeah.
All right, and just sorry to jump in, but there was another good question here about, did you, with the Nillumbik example, did you have any information around, once they put the battery in, how did that contribute to greenhouse gas emissions reductions?
We'll talk about that later.
Great.
Yep.
Okay, thank you.
We've got a specific slide about the greenhouse gas and the environmental aspects of it. Okay, so back on this slide, another case that would make a building a good candidate for a battery would be, let's say you've got an existing building and it's got an existing grid connection, but now you're expanding your operations. You're going to be using more electricity on site, and you need to get a higher. Need to get more power, more electrical power. So you go to your poles and wires company and say, oh, we need an upgrade on our cable, and they say, yes, we can do that, but we also need to upgrade our transformer, and you need to pay this eye-watering amount of money to do that. So in that case, having a battery may be a way to get around that expense of upgrading your electricity connection. And other reasons that would be a good reason to get batteries on a community building would be if you're looking for a reputation as an early adopter of technology.
Which in many ways, I suppose councils and community energy groups want to take that leadership role. So, and that's a driver, that's a legitimate driver. So,
yeah. I'm just thinking, since we've had that question about the environment, we could skip straight forward to that slide and then come back.
Oh, I reckon keep the flow going, Andrew, is my advice. Otherwise we get a bit
All right, fair enough. Okay, so if so I've been talking about candidates for batteries, but as I mentioned, a battery is really an add-on to a solar system. So the extension of that question is, well, what's a good candidate for a solar system in the first place? So with solar, it's a lot easier to find a good candidate because the economics for solar are generally very good. And that's especially the case if you don't need a loan, if you can access funds fairly easily to pay the solar installer. You want a suitable roof, obviously, and no big trees or buildings casting shadows over the panels, because that, especially if it's casting shadows around the middle of the day, then that can have a pretty big impact on the solar output. For a good candidate, you don't want to have issues between landlords and tenants, that sort of thing. If one person's going to have to pay for the system and then the other person's going to get the benefits, then you have to work out how to negotiate that. There are ways to do it, but yeah, just be aware of it. If you're paying a lot for your grid electricity, then that's an indication that you'll get good bill savings from a solar system. And if you use a lot of electricity per year, above that threshold I mentioned on the slide, then you especially tend to get cheap electricity plans, electricity tariffs for the energy component, which is what the solar can offset. Consistent daytime electricity consumption is a good candidate for solar panels, because then you've got a good correlation between when you're generating and when you're consuming. So you're consuming that solar electricity directly, which offsets that grid bill directly. All right, let's just talk about the batteries themselves for a little bit. So batteries are chemical gadgets, and that chemical aspect of them does make them a little tricky, as you'd be aware from batteries in your mobile phones, etc. They have lifespans, for example. They can degrade over time, and the dominant chemistry for solar batteries, or large-scale batteries on buildings, is now lithium. Same general class of chemistry as phones, laptops, cordless tools, electric vehicles, etc. Within that lithium chemistry, there's various different subcategories. One of those is lithium iron phosphate, LiFePO4, and that's sort of a little bit on its own category, and then there's a whole bunch of other chemistry is generally called lithium ion, like ION rather than IRON. So an example of that would be NMC, which is nickel, manganese, cobalt. So yeah, just because something's lithium, that doesn't tell you everything you need to know, I guess. And there are subvariants within that. Trends in the marketplace. So there's heaps of solar going on everywhere, on homes, on larger buildings, solar farms. By comparison, batteries are not going in anywhere near the same sorts of volumes. So from a household perspective, we've got millions of homes with solar now, and the numbers with solar batteries is probably in the tens of thousands. So yeah, relatively slow uptake. Looking at the cost of batteries, we did a study on this in 2015, and on the economics of batteries that was for households. And that little picture at the bottom is about that study we did. And there we went and looked at all the analysts, all the gurus that had predictions as to what might happen with battery prices. They were talking about reductions maybe 8% per year, 9% per year into the future. So based on that, we projected that maybe by 2020, for households, batteries might start to become generally economic. Unfortunately, those prices haven't really occurred. So batteries are still expensive, and it's hard to say why, but one explanation is just supply and demand. There is a fair demand for batteries, not so much as solar batteries, but electric vehicles, big batteries in the grid, laptops, etc., etc. So we probably need to see the supply demand even up a bit, and of course technology improvements.
Just on that, so there's different types of battery technologies. I suppose you could go to Renew, or lots of publications to kind of look at the the description and pros and cons. Yeah. There's a question here about non-lithium batteries, options around them. Hang on, I'll just read this. So are non-lithium batteries a possibility given the environmental issues with lithium?
Possibility, yes. Probably the most environmentally friendly battery in terms of end-of-life disposal and all those sorts of questions. There was one called Aqueon, which is a aqueous, basically saltwater battery. The company in the US went into Chapter 13 bankruptcy, and it hasn't really been a thing since then. Yeah, I don't think you could actually get one of those installed now if you wanted to. There have been other technologies out there. There was a flow battery, for example, an Australian company called Redflow had their battery, Z-Cell it was called, and yeah, that still is a thing, but they've retargeted their market more to off-grid telecommunications and some specific niche sort of industries. So again, it's hard to find. It'll be hard to find someone to install that. So really, it's lithium, which is where the market's at now. Yeah.
So again, I think there's in one of the resources at the end, you talk about some links to if you want to look at different types of battery technologies.
That's right.
There's a question here about has Renew calculated economic cases for batteries for buildings where the capacity charge is a very large part of the building's electricity cost? Are there cases where the savings on the capacity charge makes the battery more economic?
Short answer is yes. Yes, we have calculated a few of those cases for clients and with our consulting services that we offer. So just to explain, capacity charge or demand charge is probably the more precise term. Is where you'll still pay something for the energy that you're using, like per kilowatt hour, but some of the cost of your bill has moved into a charge per kilowatt of power of instantaneous demand. So if you have, for example, if your main load is air conditioning, then if you have a heat wave in January, which spikes up your demand at say 7 p.m. at night, then your retailer will record what that level of that demand was in kilowatts, and they'll be basing part of your bill off that number into the future for maybe the next year or so. So that gives you an incentive. If you can reduce that peak at that specific time, then that's going to have a pretty significant impact on your bill. And yes, batteries can do that. The challenge is that how do you deploy that battery capacity? Because if you see that you're in a peak, do you blow all your battery capacity on that peak? And oh yes, we've done really well. We've reduced that peak, but then maybe the next day or even the next hour, you get another peak, and now you've got no battery capacity left to use to reduce it. So yes, it's possible, but yeah, you really have to get into specific situations on that.
Yeah, thanks, William. Good question, William. Thanks, Andrew. Okay.
All right. So next few slides, we're going to focus on households. And yes, there are heaps of different batteries out there in the market. I've just put up a few images of the ones that are on a specific list. It's a Clean Energy Council approved battery list. But yeah, there's many more out there. All right, so Solar Victoria are offering rebates for battery installations, but it's pretty specific conditions. They're only doing 1,000 per year. You need to have at least 5 kilowatts of solar. It's only for households where you own the house. So if you're a renter, that's not going to apply. And even more restrictive, it's only in a bunch of postcodes that you can see on the next slide here. So yes, there are rebates, but it's not a general thing to get too excited about. Okay.
Just a couple of questions before you go on, and they've just come through. Back to the couple of slides where we're talking about different battery types. Any commentary on the supercapacitor battery?
Yeah, right. Supercapacitors and ultracapacitors. So capacitor is I was explaining batteries are chemicals, so they use a chemical process. A capacitor is different. It's more like static electricity, like when you brush a carpet or whatever. But they achieve energy storage with an incredibly large surface area by having material that's sort of rolled up, and so you got a high surface in a battery type device. They're not really available as a real prospect for companies and households to buy. There's one product that looks like it includes a supercapacitor, but it seems that it also includes chemical batteries as well. So yeah, these supercapacitors and ultracapacitors, they hold a lot of promise for the future. They can potentially overcome a lot of the problems with batteries, with wearing out and charge rate restrictions and things, but
okay,
they're not really a thing at the moment.
Okay,
yeah,
good. Okay, if you get back, there was a quick question there that came through about when the Solar Victoria battery rebate will open up statewide. I'm sorry, we just don't have any information or any guide on that. So at the moment, it'll be a bit like that postcode. Yeah.
And it actually makes sense to target it on specific postcodes, because the reason that they're doing that is batteries can, I was explaining previously, a battery can chop off a peak, and if you've got a suburb or a part of a suburb that has where the poles and wires and transformers are stressed out, like it's a growth area, for example, and you've got all these all this new demand coming in, and the electricity distributors thinking, okay, I'm going to have to build a new substation, for example. Putting batteries in can actually help to delay or remove the need for those upgrades in the grid. So yeah, actually targeting it on specific areas makes sense, especially since the economics are not so great for bill savings in general. Okay. So there's still no proper Australian standard for installing one of these lithium solar batteries in a home, or even in other types of buildings too. There's one that's been in the process for quite a while. The standards committees had a fair bit of disputes and problems. They brought out a draft standard, but that got a lot of pushback from a whole range of different sectors, and gone back to the committee again. So when the Australian standard does get finalised, we expect it to crack down a bit more on the fire safety risks. So I won't go through them. You can see on the slide, but yeah, just be aware that batteries are going to have some more restrictions on where they can be placed than what may have been done with some installations up until now. And there's a link there that is a good sort of guide in the absence of that Australian standard. All right, a second case study. So this is a council-owned function centre, and it's used for corporate events, weddings, concerts, theatres, etc. It doesn't actually have a solar or battery, but we did do an analysis on it using our Sunulator simulation tool, and based on historical metering data from their billing meter over a year and half-hourly intervals. So what we did is we looked at the case where it had business as usual, no solar, no battery. A case where you add on 100 kilowatts of solar, and a case where you add on the solar and a 100 kilowatt hour battery. So the same type of system as what we saw on the Nillumbik example. So this chart here is just showing their historical electricity consumption day by day over a year. And as you can see, it bounces around. You have some high days, some low days. So the highest one is Valentine's Day there. I guess they had some sort of ball or something, 14th of February. The lowest one was only about a tenth of that energy consumption over the day, and that was the 21st of September, so maybe it's a grand final weekend or something. And I've just highlighted a couple other days with sort of average level of consumption over the day. This chart again is just looking at historical electricity consumption, but now I'm looking within a day from midnight to midnight, and picking out those 4 days that we just saw on the previous chart. So the red one up the top, that's the 14th of February that had the highest consumption, and they've got high consumption even at night there. So maybe they've got the aircon running all night, for example. And yeah, it looks like they've got an event at night time as well on that day. The blue one down the bottom, Sunday 21st of September, looks like there's no event. There's basically I guess they've just got the standby fridges and computers and security systems and that type of thing going. And then the green one and the purple one would be days when, so the green one is where they had a daytime event, and the purple one's where they had a nighttime event. So you can sort of start to imagine that with this centre, some days are going to match up, your consumption is going to match up with the solar generation really well. That correlation will be quite close, like that green line. Other days, like the purple line, you're going to be exporting a lot during the day and then importing a lot from the grid at night, unless you have a big battery. So that's this. So a purple day like that is where a battery might be quite useful. So with the simulations, we looked at that. So with that red line on the Valentine's Day, the consumption was so high all through the day that the power generated by the solar panels goes straight into the appliances used in the building, which is a good thing. But there was none left over to charge the battery. So the battery started off the day empty, and it's just empty the whole day. So this is something to be aware of, that just because you've got a battery that has some, you know, energy storage capacity, it doesn't mean that that capacity is necessarily going to be cycled every day. So there'll be some days when you actually don't get much usage out of the battery at all. And then there's a couple other days there where, yeah, that green line, the battery only got to charge up to 40% of its capacity. Again, because during the day there was a pretty high consumption that was soaking up all the solar. And yeah, on the blue line, you would think the battery would charge up quite a lot because there's not so much consumption, but it happened to be quite a poor day. It must have been dark, cloudy, rainy. So you still didn't get a full battery charge even on that day. So I guess the takeaway is, yeah, don't just assume that the battery is going to behave in a simple way. It does change from day to day, especially if you've got a facility that has different behaviour on different days.
So is it where the facility, the use is a little bit unpredictable?
Yeah.
So, you know, there's, as you can see in that example, there's some evening time use where it's high, and then other evening time use where it's not high. So it's that consistency isn't there to
Yeah, that's right.
allow the battery to come into its own. Yeah,
that's right. So if you're looking for a site that's really consistent, maybe a nursing home, for example.
So somewhere where there's a consistent load overnight, like lots of air conditioning, HVAC. Well, what about IT, you know, server type function? You know?
Yeah, IT stuff.
Yeah.
And that's another one where you've got a consistent load.
Yeah, okay.
Yep. All right, so had a look at the economics as well. So if you put solar on, then it was going to get a bill saving of a bit over $15,000 over a year, and payback time on the solar was about 9 years. Now that's reasonably long as a payback time for a solar system. Households in Victoria, you're looking at payback times, you know, 4 to 7 years, that sort of thing. For this community function centre, their tariffs were, their electricity grid tariffs were quite low, and especially that energy component was quite low because they had one of these demand charges that we just talked about previously. So that reduced the available bill savings. If you're not paying that much for your energy from the grid, then getting it from solar is not going to provide as much of a big benefit. With solar and battery, their annual bill saving increased, but only by about an extra $1,000. So once you take into account the upfront cost of the battery, the payback time blew out to 18 years. And that's something that's not too uncommon with the analyses I've done on batteries. When you look at the payback time just of that battery component, adding on that battery cost, you do get some pretty long payback times. So the key messages, I guess, is get some analysis done before you invest a lot of money in an expensive battery. Make sure you consider the solar without battery as well as the solar with battery case. So you can ask for quotes from the solar installer for both cases. So you can clearly see how much additional upfront cost that battery is costing you. And oh yeah, another point is when you're doing an analysis, you're generally looking at historical meter data over the last year, for example. But just be mindful if your future electricity consumption is going to change. So are you going to expand your operations? Are you going to maybe have electric vehicle charging in the future? These are the sorts of things to consider as well.
Just, Andrew, that's a good segue, because there was a comment, question or comment, probably more a comment coming through about interested in the developments of vehicle-to-grid offerings, so that electric cars can offer power back to the site during evening peak electricity times when solar isn't running, or then recharging this car overnight on a lower tariff. So just any comments on that?
Yep. So vehicle to grid charging, that is possible, it can happen. The big thing to check is whether it's going to affect your warranty on your electric vehicle, because the car manufacturer has, they've designed this battery for a specific sort of use pattern for driving it. If you're going to also be flogging it every night to interact with the grid, then if you had an issue with accelerated aging of the battery and you went back on your warranty, they might say, oh, hang on, you haven't just been using this for driving, have you? So check that out first.
Yeah. So that's a current state, but I suppose it's one of those things, as I suppose EV become more prevalent, technology improves, then that becomes, an option to think about.
Yes, so certainly is an option to think about, and it can be especially useful for the grid to help shave off those peak demands. So if you have a heat wave in Victoria and you're going to get a peak demand in a suburb at 7 p.m, then even if you're just taking a little bit of power out of the battery and just to put that into the grid and help offset that peak, then that could help out the grid a fair bit. Yeah. There's a couple of slides here that I get to have a rest, I think.
No, I just wanted to raise a couple of these. I suppose with our work and our discussions with councils there's a movement to councils looking at where they might be able to use batteries on community buildings, and I suppose it's interesting to learn from them. There's a couple of pictures there on the screen that you'll see that taken at a council, and I suppose that council had found the experience pretty good, and their lessons, when we asked them if you were kind of sharing this experience with other councils, what would you say? And I suppose they said really pay attention to the comprehensive commissioning, testing and handover phase. That was their takeaway. And also making sure that you integrate energy monitoring with every installation. So without that, there's risks that a whole lot of things that Andrew will come up with. So that was sort of a worthwhile point I wanted to raise. And this other one was, on the other side of things, it doesn't always go to plan, and that, sometimes you can experience difficulties with this sort of project like this. So, again, learning from councils, their experiences, sometimes making sure that the batteries are connected to the correct load circuits to deliver savings. Also, just be aware that sometimes, you're working with installers that, very confident, but maybe they, look at their track record, I suppose, in terms of doing battery installs, and particularly battery installs, on these types of buildings. So, yeah. Also, data monitoring is not always standard with every installation. So again, think about that in terms of your scope of work or your design of the project. And it comes back to that earlier point, when you don't have the proper monitoring in place, often there's system faults that can take a while to become apparent. And that affects the value that you're getting out of that project, and definitely affects the economics. All right, back to you, Andrew.
Okay. So yeah, that leads well into a slide that I had. I'm not going to go through every point on this one, but just some if you are putting in a battery, just some things to watch out for. So on the economics, what a solar installer will often do is say, okay, here's a solar and a system including a battery, and the system will pay for itself in 8 years. It'll save you this much per year. All looks good. What they've done is they've rolled in together the economic benefits of the solar panels as well as adding on the battery into the system too. So if you ask them for a quote for just the solar system but without the battery, then you might find payback of 4 years, and the upfront cost is a lot lower. So, and your annual bill saving won't be quite as much if you get rid of the battery. So yeah, ask for a quote both with and without a battery, so you've got a clear picture of both options. Where you put a battery can affect its lifespan or its aging. So a hot location is not great. So anything you can do to keep it cool with shade or even air conditioning. There are people who've where they put in a battery system in a shipping container, for example, and then they've installed air conditioning in the container to make sure the batteries stay at a nice temperature. And yeah, you might think that the air conditioning is expensive, but not compared to the batteries themselves. Installers, if they're inexperienced or if they're just under time pressure because they've been subcontracted, for example, and they're only being paid a relatively low fixed amount, then watch out for that if they're going to do a rush job. And also look at the warranty conditions on the batteries pretty closely too. All right, so the environment. So we had a question on this, and there is quite a lot of confusion about what the environmental impact of batteries is, and because often people just sort of take a simple view, and they're just looking at what their building or what their home is going to import from the grid, and they say, well, okay, so if I just have solar, then I'm reducing my imports during the day. If I have a battery, then as well as the solar, then I'm reducing my imports from the grid during the day and also at night. So that's got to be better for the environment. But it's not that simple, unfortunately. You do have to take a bigger picture view of it. So let's take a case where you have 5 houses and they're supplied by a coal-fired power station. Now, obviously, this is a simplification because a coal-fired power station needs to supply a lot more than just 5 houses. But just as an example, so if you've got no solar there, then the coal-fired power station is going to be emitting pollution, greenhouse gases, in proportion to the load that it's supplying. So five houses, I've put 5 little puffs of smoke to indicate that level of pollution. And on the right is the chart of how the coal is being burnt over the day. So let's assume all the houses are identical and that they've all got a bit of a morning peak and they've got an evening peak as well. So the coal burning without any solar, the coal burning is just going to match that profile of electricity consumption in the houses. Now, there's a bit of a misconception that coal-fired power stations can't vary their level of generation and coal burning. Actually, they can. Maybe if you go way back into the past, there were some that could only go at a single rate, but the power stations we've got now, they can vary their level down to 50%, 33%. So yeah, that it is realistic that the output of a coal-fired power station will vary. All right, so the second line, we've got where one house has put on solar but no battery. So when it's nice and sunny, that house is going to be supplying itself, and it's also going to have excess, which is going to flow out through their billing meter into the poles and wires in the street and into their neighbours. So during the day, you're going to have more than 1/5 reduction in how hard that power station has to go. So you can see that in the chart. We've got a big dip during the day there. So that means it's not burning as much coal. So if we say that over a year that solar system is generating the same amount of energy as what that house is consuming, then over a year that power station is only going to burn 4/5 as much coal. So I've just got the 4 little puffs of smoke now. All right. So if the house has the solar and they add a battery as well, during the day, yeah, well, there are some. Let's just keep it simple and assume that the battery is soaking up pretty much all of the excess solar. So now that house is not sending out, it's not sharing its excess electricity with the neighbours. So during the day, the coal-fired power station, it's going to be reducing its output compared to if there was no solar, because that house with the solar its appliances are being supplied by the solar rather than from the grid. But it's not going to be reduced as much as the second row. And then during the evening, that house with the solar and battery, yeah, the battery is going to be powering appliances. So we have a reduced coal burning in the night as well. So yes, we've reduced the amount of coal being burnt, but only to the same extent as the second row. It's all the battery's done is it's time shifted the generation of the solar, and it's time shifted the reduction in the coal burning. But over a year, the second row and the third row still burn the same amount of coal. So batteries, as a direct effect, they're not really helping the environment. So we can talk about specific cases where solar would have been wasted otherwise, where you can't export it, you can't share it with your neighbours, then yeah, having the battery is going to help the environment. But at this stage, those are more exceptions. And so yeah, as a general proposition, adding a battery, it's not really going to directly help the environment.
Right, thanks Andrew. I'm conscious of time. We've got a few more, and then there's a few questions as well.
Okay, I think we're just. We don't have many more slides.
I think we've got.
So we've got the battery info resources. So I don't think I need to talk to that. Just have a look at your own leisure. And then just the takeaway messages from the presentation. So I guess the first one is if you're looking at a community building to put on batteries as well as solar, then yeah, take the time to understand whether it's a suitable candidate and what the real benefits are going to be. So to do that, there are some resources available. Sunulator we mentioned previously, so there's a link to that. Some of you guys, I think, would already come to a training course on that. We've done quite a lot of training courses already. And yeah, talk with other sites. Information sharing, knowledge sharing is always a good thing. If you're looking at batteries, don't let that delay you from putting on the solar, because the solar panels they're the component that give the environmental benefit, and they're also generally very economic. So it's quite possible to put on a solar system and then wait for things to evolve with batteries and add them later on.
Okay, just a couple of questions. So you mentioned Sunulator there. There's a good question here about, is the Sunulator going to be modified to cater for time varying feed-in tariffs?
It's interesting, that one. So we've got a free version of Sunulator that's available for download off our website. We've also got an in-house version that we use for our own projects and things. that's not available for free download. So the free one can't handle time varying feed-in tariffs, but our in-house one can. We would love to make that version available for free download, but being a not-for-profit organisation, we don't have the funds to just go ahead and do that. We need to find some funding to make that happen. So if there's any suggestions out there, but by the way, as well as time varying feed-in tariffs, we also have overshadowing and building up consumption profiles with air conditioners, hot water, and a whole bunch of things. Extra battery logic. So,
all right, good. Another question here. Is a key role of batteries to reduce peak demand during hot weather and evening peaks? This can reduce the need for peak diesel generators or open gas cycle plants operating.
Yep, that's true. Yep. So let's say that heat wave in Victoria again. Everyone comes home at 6 o'clock, 7 o'clock, turns on their air conditioners, ovens, TVs, etc. You have a spike in the electricity consumption in a suburb or in Victoria as a whole. When that happens, all the generators in the grid need to come in, including the gas, diesel perhaps, etc. Diesel's are only about as dirty as coal, and the gas, open cycle gas, is probably a bit less dirty than coal. So it's not really if you're looking at the dirtiness of the grid, the peak's not such an issue. It's more around the expense and the augmentations that need to go into the grid to meet the peak demand, and that's where batteries can have a good economic benefit.
A question came in back to the first example, which was the Nillumbik example. Did you have any information around the payback period of that project? You know, how those economics? I mean, obviously it happened because it had a state government grant as well.
Yeah.
So did you have any information on that?
Unfortunately, no. I don't have any info about their bill savings.
Yeah. Okay. Barbara's got a good comment here about batteries, and we haven't really touched on the end of life batteries, recycling.
There is one facility in Victoria that is recycling lithium batteries at the moment.
Yep, and also I suppose with batteries, the whole of life cycle costs, including resource extraction, processing. So they don't really get factored into any sort of consideration of economics, do they? No.
Usually you're just looking at the purchase price of the battery and comparing that to its economic benefits over its lifespan. Lithium does have some concerns about how it's extracted, and also some of the other elements that some of the batteries use has some concerns as well. So good to check that out.
Good. Okay, we're getting towards the end. I think if you wouldn't, Andrew, if you could just sort of touch on again the types of community buildings that are going to stand up as stronger candidates for these sort of scale batteries.
I would think as good candidates for batteries now, it's not so much about the economics. It's more about facilities that need to have that ability to keep running in a blackout, in a grid blackout. So bushfire refuges, nursing homes, any sort of mission critical facilities that, especially if you're in an area that is prone to blackouts. It's surprising how frequent they are out in the bush sometimes when you've got long lines with lots of trees waiting to fall on them, that sort of thing. So it would be those or the ones where they've got issues with the local grid that a battery can specifically help with.
Okay, we've got a few more minutes. Any last minute questions, please send them in. I think we've pretty much dealt with the comments that have come in so far. I do note some of you have had a few problems with the audio and video. It doesn't seem to be across all participants, so it might be a bandwidth problem or yeah, so apologies for that, but hopefully the recording will be able to make sure that you haven't missed anything. Okay, thank you, Andrew. I really hope everyone has found that useful. It's a short period of time to cover a really complex topic, and one that is changing, as technology changes and other things. So, here's a nice one. Any ideas when batteries might hit the sweet spot?
For economically?
Yeah.
It's just so hard to predict. I mean, I in that slide, I was saying that in 2015, we thought it might be 2020, but that's not going to happen. So, yeah, look, maybe a few years, maybe 5 years. Hopefully, there'll be a breakthrough with the battery technology and the chemistry, and they can suddenly make them cheaper or a higher capacity for the same size of battery. But yeah, we'll just have to see.
Andrew, what about the growth in EVs taking up obviously the resources where they can extract material for batteries? That means that there's a greater demand on the input. So, EVs suck it up, household batteries or community scale batteries don't necessarily got to compete for that. So prices are high.
Yeah, and it's a bit of a sort of two-edged sword, I guess. If with EVs scaling up, as we're seeing with all these auto manufacturers that are really switching over their strategies towards EVs, so that is going to put pressure on the supply chain for batteries. But on the other hand, once those supply chains catch up, now you're talking big economies of scale, which is going to help the prices to drop. So yeah,
great. All right, we've come to the end of the hour. Thank you everyone for joining in and being part of it. Special thanks to you, Andrew and Renew. Please, when you get the slides and the recording, feel free to share it within your network. It's just introducing or touching on the topic. There's a lot more to it. So, but if we've got a network here, we're really happy to share information. If you are a council or a community energy group that not currently connected to anyone that has had experience with batteries, and you want to sort of, have a conversation and learn from them, please reach out. We're happy to connect the dots and, get people to share their experiences of what worked or what hasn't worked. We'll help out there. And also, we're interested in your feedback. There's some nice thanks to the feedback. If you've got any other ideas about topics, please shoot them through. You'll have the email from me when I send out the recording and the slides. And if you've got any other ideas of topics, let us know. It's a good way of reaching a wide audience, particularly in regional areas. Thanks.
Thank you, Luke.
No worries.